In this section, we'll look at a type of interest that you're more likely to encounter in real life, and you may be familiar with this from your savings account. This is called compound interest. Compound interest has geometric growth, which means that its growth is proportional to the amount of money currently in the account. So as the amount of money in your savings account grows, so does the amount of interest you earn. And the amount grows in a curve that gets steeper as more time passes. Again, compound interest is interest that is paid on both the original principal and on the accumulated interest in your account. The compounding period is the fundamental interval on which compounding is based, and this is how often interest is calculated and added to your account. Differences in compounding periods can make a difference in the amount of interest you are earning on your account. So let's take a look at this chart here. And this compares the amount of interest you earn with the same annual interest rate starting with $1,000 but with different compounding periods. And you can see that the more often the interest is compounded, the more interest you're going to have. But there is a limit to how much interest you can earn by compounding more often, and this is shown in the far right column labeled compounded continuously. We'll look at this in the next section. Let's talk a little bit about interest rates. A nominal rate is any stated rate of interest for a specified length of time, and it does not take into account whether or how often interest is compounded. So in that chart on the last slide, all of those had an annual interest rate of 10%, but it didn't tell me anything about how often interest was compounded. The effective rate is the rate of simple interest that would realize exactly the same amount of interest over the same amount of time. So that is the simple interest rate that would give me the same amount of money at the end. So for 1 year, the effective rate is called the annual percentage yield, and you'll often see the annual percentage yield, or APY, given when you're looking into different types of accounts to invest in. Let's take a look at a short example. If you have $1,000 at 10% compounded daily, after 1 year you'll have $1,105.16. This is the same amount you would have if you had simple interest calculated at the end of the year at a rate of 10.516%. So that means the effective rate for 1 year, which is also the annual percentage yield, is 10.516%. So even though the nominal rate on this account would be 10%, the APY is slightly higher. Now let's look at how to calculate compound interest. First, we need to find the periodic interest rate. So for a nominal annual rate R compounded m times per year, the rate per compounding period, or periodic rate, is given by R divided by m. So that is the nominal annual interest rate divided by the number of compounding periods per year. And then to calculate the amount you're going to have in your account, if you have an initial principal P that pays interest at a periodic interest rate I per compounding period, after n compounding periods, you will have A is equal to your principal P times 1 plus the periodic interest rate I to the power n. If instead of the periodic interest rate you just want to use your nominal annual rate R, you can use this formula instead, where it's given in terms of R and M. So the amount you'll have after T years is given by P times 1 plus R over M. And remember that R over M is the same as the periodic interest rate I. And now this is to the power M times T. So if you have m compounding periods per year for t years. This is the number of compounding periods that have happened. Let's look at an example. My great aunt Norma left me $5,000 in her will. I decide to invest the money in a certificate of deposit or CD at my local bank. If I get an interest rate of 3% compounded annually, how much money will I have after 1 year, 5 years, and 10 years? Well, I'm going to use my compound interest formula. So I'm going to use the formula A is equal to the principal times 1 plus my periodic interest rate to the number of compounding periods. So my principal in this case is $5,000. My periodic interest rate, I, is actually given to me, and this is 3% compounded annually. So my period is 1 year, and my periodic rate is 3%. So let's go ahead and convert this to a decimal. So I've got my decimal place here for 3%. I'm going to move it over 2 to the left. This is equal to 0.03 is the decimal form of 3%. So after 1 year, n is going to be equal to 1 because 1 year is 1 compounding period. And the amount I'm going to have in my CD is going to be $5,000 times 1 plus 0.03 to the power 1. And this is equal to $5,150. After 5 years, that's 5 years is 5 compounding periods, so n is going to be equal to 5. Then the amount I'm going to have in my CD is 5,000 times 1 plus 0.03 to the 5th power for 5 compounding periods. If I put that in my calculator, that's going to give me $5,796.37 in my CD after 5 years. Finally, let's look at 10 years. So now that's 10 compounding periods, so n is equal to 10. The amount is going to be 5,000 times 1 plus 0.03 to the power of 10. And that's going to give me $6,719.58 in my CD after 10 years. So here I've got that rewritten, and I've also made a graph to show the difference. You can see what I had from the last section when I had a CD with simple interest is the green line, the lower line here. Compounded yearly in this example is the purple line, and I've also added a blue line for compounded daily, which you can see is a little bit higher, but not too much higher than what I have if my interest is compounded yearly. Let's look a little more at the effective rate. So we said the effective rate is the simple interest rate that you would need to get the same amount of interest. So for an interest rate I per compounding period, the effective rate of interest for n periods is given by this formula, 1 plus I to the n minus 1. For a nominal annual interest rate R compounded m times per year, the APY is given by this formula. And here we've just replaced I with R over m and n with m. It's the same formula, but written a little bit differently. So let's look at an example of that. Suppose you invest $1,000 at 10% nominal interest per year in a money market account. If the interest is compounded monthly, how much will be in the account after 10 years? And what is the APY? Well, first I want to find the amount that I'm going to have after 10 years. And I'm going to use my second formula for compound interest with the nominal rate and the amount, the number of times that interest is compounded per year. So A is equal to P times 1 plus R divided by M to the power of M times T. Now here my principal P is the amount I start out with is $1,000. My nominal annual rate R is 10%. So if I convert that to a decimal, I'm going to move the decimal over 2 places, and that gives me 0.1 is the decimal form of 10%. M is the number of times that interest is compounded per year, and so interest is compounded monthly, then M is going to be equal to 12. And finally, I'm looking at how much I will have after 10 years. So T is the number of years is equal to 10. Now I plug everything into this formula here. So A is equal to $1,000 times 1 plus 0.1 divided by 12 to the power of 10 times 12. And if I put that all into my calculator, after 10 years, I'm going to have $2,707.04. So that's a pretty good investment. I've almost tripled my money in 10 years. For the next question, I want to figure out what the APY is, or the annual percentage yield. And the formula for APY is 1 plus R divided by M to the power M minus 1. So these are the same R and M that I had from before. So this gives me 1 plus 0.1 divided by 12 to the power 12 minus 1. If I plug that into my calculator, that's going to give me 0.105 is my interest rate. So this time I want to convert that from a decimal back to a percentage. So I'm going to move the decimal point to the right 2 places. So 1, 2, and this is equal to 10.5%. So the APY is actually a little bit higher than the nominal interest rate. That finishes up this section. Things you should know. You should be able to calculate compound interest given the principal, nominal annual rate, and compounding period. You should also know that compound interest is paid on both the principal and the accrued interest in your account, and that it grows geometrically, which means that it grows in a curve that gets steeper as you go over. So geometric growth is going to look something like this. It gets steeper, whereas for simple interest we had linear growth, which is just in a straight line.